I could touch you, so I do.
You are welcome to Excellent Touch Tutorials. My name is Sir Isaac. In my last video, I discussed on the definition of science, categorization of science, as well as the difference between pure and applied sciences. In case you have not watched it, use the link provided to access and watch it. In this video, I'll be sharing on the careers that physics can position you to study and practice in the future. Now, let's dive into it. Career prospects in physics. First, I'd like you to note that physics is a fundamental subject that underlies many areas of science and technology, offering a wide range of career prospects. A good understanding of physics will position you to study and practice in the engineering field, the medical field, the information and communication technology field, the field of research, and educational field or teaching. Now, we shall look at some of the practices in each field or discipline under the following headings. First, the traditional practices. Traditional practices refers to the most known or the most common practices in the field. It is also the most relatable because they are famous. Second, the specialized practices. Specialized practices are practices with unique requirement of advanced knowledge, skills, and training. And then third is the interdisciplinary practices. Interdisciplinary practices are practices that combine or integrate knowledge from various fields or multiple disciplines to address complex problems. The fourth one is the emerging practices. The emerging practices refer to the new developing area of expertise in the field. So the first field we're going to be looking at is the engineering field. The engineering field is a field or discipline of applied science that is concerned with the design, fabrication, and maintenance of engines, machines, devices, as well as structures that make life better and easier. A person who practices engineering is called an engineer. Here are some common practices in the engineering field. First, let's look at the traditional practices in the engineering field. They are aerospace engineering, which designs aircraft, spacecraft, and missiles. Agricultural engineering, which develops efficient farming systems and equipment. Biomedical engineering, which applies engineering principles to medical devices and procedures. Chemical engineering, which develops processes and equipment for chemical manufacturing. Civil engineering, which designs and builds infrastructures such as roads, bridges, and buildings. Electrical engineering, which works with electrical systems, including electrical circuits, electronics, and so on. Environmental engineering, which develops solutions for environmental protection and sustainability. Mechanical engineering, which designs and builds mechanical systems, including engines and machines. Next, let's look at the specialized practices in engineering. The first on the list is acoustical engineering, which deals with sound and vibration. Next is audio engineering, which focuses on audio equipment and technology. Next is automotive engineering, which designs and develops vehicles. Next is ceramic engineering, which works on ceramic materials and processes. Computer network architecture, which designs computer networks and systems. Next is construction engineering, which manages construction projects and sites. Next to that is control systems engineering, which develops control systems for machines and processes. Next to that is cyber security engineering, which protects computer systems and networks from cyber threats. Now we're going to talk about the interdisciplinary practices in engineering. First, on the interdisciplinary practices in engineering is biomechanical engineering, which applies mechanical principles to medical devices and systems. Next to that, we have biochemical engineering, which develops processes and equipment for biochemical manufacturing. Computational biology, which uses computational methods to analyze biological data. Next, we have environmental biotechnology, which develops sustainable solutions for environmental protection. Next to that, we have geophysical engineering, which applies geological principles to engineering problems. Next, we have material science engineering, which develops new materials and material processes. Next to that, we have nanotechnology engineering, which works with materials and systems at nanoscale. And then we have neuroengineering, which develops devices and systems to interact with the brain. And the list goes on. These are interdisciplinary practices in engineering. Let's go to the next field, which is the medical field. The medical field is a field of applied science concerned about healing or restoration of health by diagnosis, treatment, and prevention of diseases. This consists of medicine, pharmacy, nursing, just to mention a few. The medical field is very broad. However, here are some common practices in the medical field. The general practices. General practice is a primary care for everyday issues. It could be for families, what we call the family medicine, or individual adults, also called internal medicine. It focuses on prevention and treatment of illness. A person who practices general medicine is called a doctor or physician. Next is surgical practices. Surgical practices is performing operations to repair or remove damaged tissues in the body. Here are some of the surgeries. First is orthopedic surgery, which is surgery on bones, joints, and muscles. Next is neurosurgery, which is surgery on brains, spinal cords, and neurons. Next is cardiothoracic surgery, which is surgeries on hearts, lungs, and chest cavity. Next is pediatric surgery, which is surgical care for infants, children, and adolescents. Next to that is vascular surgery, which is surgery on blood vessels. Next is plastic surgery, which is reconstructive and cosmetic surgery. And the list goes on. A person who performs surgery is called a surgeon or a surgical doctor. Next to that is specialized practices. These are practices with unique requirement of advanced knowledge, skills, and training for diagnosis and treatment of disorder of specific body parts. Here are some of the specialized practices, the person's identity, and the specialty. First is cardiology. A cardiology doctor is called cardiologist, and a cardiologist treats the heart and blood vessels. Next to that is dermatology. A dermatologist treats skin, hair, and nails disorder. Next to that is psychiatry. A psychiatrist treats mental disorders. Next to that is neurology. A neurologist treats brain, spinal cord, and neurons disorder. Next to that is oncology. Oncologists treat cancer. Next to that is urology. Urologists treat urinary tract and male reproductive system disorder. Next to that is ophthalmology. Ophthalmologists treat eyes and vision disorder. And next to that is otolaryngology. Otolaryngologists treat ear, nose, and throat disorder. Anthologist is also known as ENT doctor. Now let's look at diagnostic practices. First on our list of diagnostic practices, we have radiology, which is about medical imaging interpretation using CT scan, X-ray, and MRI. Next is pathology, which is about laboratory testing and tissue analysis for diseases diagnosis. Other practices are emergency, critical care, as well as subspecialized practices such as immunology, hematology, rheumatology, nephrology, and so on. Now, the information and communication technology field, ICT. ICT stands for Information and Communication Technology, which refers to the integration of information technology as the computers, the software, the data storage and processing, as well as communication technology. ICT encompasses a broad range of technologies used to create, store, and manage digital information. ICT facilitates communication and collaboration. ICT supports various aspects of modern life, from education and healthcare to business and entertainment. Now, ICT includes first hardwares such as computers, servers, smartphones, and other devices. Next is softwares such as applications, operating systems, and programming languages. Next is networks, which includes internet, intranets, and extranets. Next is digital media, such as text, images, audio, and video. ICT has transformed the way we access and share information, and the way we connect and communicate with others, the way we work and collaborate, and the way we learn and educate, the way we entertain and socialize. ICT is a very vital part of modern society, and its impact continues to grow and evolve with new technologies and innovations. Here are some common practices in information and communication technology field. The common practices. First is the artificial intelligence, AI, which develops intelligent systems to perform tasks that typically require human intelligence. Next is cybersecurity, which protects computer systems and networks from cyber threats. Next is data analytics. Data analytics examine data to gain insight and informed business decisions. Database administration manages and maintains database. Help desk support, which provides technical assistance and support to users. Then the network administration, which manages and maintains computer networks. Then we have software development, which creates software applications and systems. Then we have system administration, which manages and maintains computer systems. Others include digital forensics, information architecture, IT project management, network security, software engineering, technical writing, telecommunications, web development, web design, and so on. What are some of the specialized practices? Specialized practices include blockchain development, which builds secure and decentralized applications using blockchain technology. Cloud computing, which develops and manages cloud-based systems and infrastructure. DevOps engineering, which bridges development and operation teams to improve collaboration and efficiency. Digital marketing, which uses digital channels to promote products and services. E-commerce development, which builds online shopping platforms and systems. embedded system development, which creates software for embedded systems like microcontrollers, game development, which creates games for PCs, consoles, or, or mobile devices, human computer interaction HCI, which designs users' interface and experiences. Others are Internet of Things IoT development, IT service management, machine learning engineering, mobile app development, natural language processing, quality assurance engineering, robotics engineering, social media management, user experience design, virtual reality development, and so on. The emerging practices in the ICT include quantum computing, which develops computing systems that use quantum mechanics to solve complex problems. Next is edge computing, which processes data closer to where it's generated, reducing latency. Next is extended reality development, which creates immersive experience including VR and AR. Next is artificial general intelligence, which develops intelligent systems that can perform any intellectual tasks. Next to that, we have digital twin development, which creates visual replicas of physical systems to stimulate and predict behavior. Others include nanotechnology, neuromorphic computing, swarm intelligence, and so on. Now let's look at teaching or the educational field. Teaching is an act or art of transferring knowledge to others. A good understanding of physics could make you a master of it, positioning you to share your knowledge and inspire future generations by teaching physics at various educational levels, such as high schools, colleges, polytechnics, and universities. Physics teachers typically develop and implement engaging lesson plans to explain complex physics concepts, conduct lectures, discussions, and laboratory experiments to facilitate student learning, assess students' understanding through assignments, quizzes, and exams, provide individualized support and guidance to students, stay updated on development in physics research and education to enhance teaching methods. Physics teachers may specialize in areas like theoretical physics, experimental physics, physics education research, and science education. Effective science teachers possess strong knowledge of physics principles and concepts, excellent communication and teaching skills, ability to inspire and motivate students, patience and empathy in addressing students' difficulties, and continuous learning and professional development mindset. By sharing their passion for physics, teachers inspire future generations of scientists, engineers, and critical thinkers. Now let's have our test of knowledge. List 5 broad fields of science where you can be relevant with a good understanding of physics. Next, what is the medical field concerned about? And lastly, what is the job of a cybersecurity engineer? Share your talk responses with me in the comment section below. And here is your assignment. First, which career are you interested in? Make a research on the career of your choice under the following headings: name of career, job description of the career, relevant subject or courses to study, the university of your interest that offers that course, and then share your findings with me. Now, which area can we apply the knowledge of physics? Career prospect in physics, which we just looked at, hinted this. However, in my next video, I'll be sharing on the application of physics in a more detailed manner. If you like this video, please be sure to click the like button, subscribe, and leave a comment. I will see you in the next one.